Physical changes. Okay, please write down the definition. Physical change is any change that alters the form or appearance of matter. If you end up with the same chemical substance after the change, but it just looks different, it was a physical change. Write this down as well. Please write down a list of examples. All of these are examples of physical changes. In each case, the object looks different at the end, but it is still the same matter. It is not changed into anything new. An example of a physical change involving ice would be melting it, evaporating it, or condensating the water vapor, or freezing the water. In all of these changes, you still have the same substance. You have H2O. It just changes form and looks different and behaves differently, but it's still the same substance. So these are examples of physical changes. When a solid is heated, the temperature rises and it warms up until it reaches a particular temperature, and that temperature then remains the same while the liquid is being formed, while the solid is breaking down and becoming more loosely packed and able to move around. That temperature for water is 0 degrees Celsius. Then the liquid, once it's all turned into a liquid, then the temperature can continue to rise until it hits another plateau. This is now the temperature at which the water will boil. For water, this is 100 degrees Celsius, and while the water is boiling, the temperature does not rise. Only after all of the liquid particles have turned into gas can the temperature then continue to rise. So ice can never be at a temperature above 0 degrees. Liquid water can never be at a temperature above 100 degrees. When the gas is cooled down to 100 degrees, it will condensate. When it cools down to 0 degrees, it will freeze, and then it can continue to get colder after that. You need to know the difference between boiling and evaporation, so you can write these down. Boiling occurs at one temperature. Evaporation can occur at any temperature. Boiling is a quick process. Evaporation is a slow process. Boiling takes place throughout the liquid, and there are bubbles formed in the liquid, whereas evaporation takes place only at the surface, and there are no bubbles formed, and the temperatures are different as well. Now you can see that here, evaporation, only the very surface molecules have enough energy and room to escape layer by layer, whereas in boiling, all of the molecules of the liquid have been energized enough to turn into gas, so you get gas bubbles forming throughout the entire liquid, and they escape to the surface and spread out. In evaporation, only those surface molecules have enough room and energy to make it into a gas state. Sublimation is an odd change that is only seen by a few substances. It's going from a solid to a gas state without passing through the liquid phase at all. Carbon dioxide does this. It's called dry ice when it's in a solid form, and it will sublime directly to a gas without turning into a liquid at all. The element iodine also does the same thing. Iodine as a solid is a dark purple, almost black colored crystal, and it will turn into a purple vapor without becoming a liquid first. Write that down, please. So this is a triangle that shows you all three states of matter and how it changes between them. So you should copy this down with all of the words that go with it. So solid to liquid is melting, liquid to solid is freezing. Liquid to gas is vaporization. Vaporization can be either boiling or evaporation. Gas to liquid is condensation. If it goes from a solid directly to a gas, it's called sublimation. And if it goes from a gas directly to a solid, it becomes deposition. That can happen up in the upper clouds when you have gaseous water vapor and then it turns into ice and then falls. That would be sleet. Or if it turns into a snow and then falls, that would be an example of deposition. As you go from a solid to a liquid to a gas, it gains more energy. So that arrow is on the side. Now, just like with a chemical change, the mass before and after the physical change remains the same. None of the matter is created or destroyed. It just looks different. So if you measure the mass of a glass of milk and the mass of some chocolate powder, and then you mix them together to make chocolate milk, the mass of the chocolate milk will be equal to the mass of the milk and the chocolate powder added together.